Hello students, let me introduce myself. I am Dr. Madhusudhan, working as an Associate Professor of Chemistry, B.V. Raju Institute of Technology. Okay, today I am going to discuss about liquid fuels. Liquid fuels. 1. Fractional distillation, extraction, refining and fractional distillation of crude oil. 1. 2. Synthesis of artificial petrol. 3. Cracking. In this cracking, you are going to study only moving bed catalytic cracking. Moving bed catalytic cracking. So in the syllabus, you have only moving bed catalytic. What is cracking? Example and synthesis of gasoline from using moving bed catalytic cracking method. 3. 4. Knocking. These are the 4 topics I am going to discuss with you. First one, extraction, refining and fractional distillation of crude oil. Basic question. Where do we get crude oil? Crude oil is abundant in Earth's crust. What is the process that we use in extracting crude oil? Simple process, just like borewell. So first step, it completes extraction of crude oil. 1. Extraction, refining, fractional distillation. So first 3 steps are involved. 1. How to extract crude oil from Earth's crust. Crude oil abundant in Earth's crust. Initially, we need to make holes. Holes can be made down to Earth's crust by drilling. So after making holes, we need to insert pipelines. 2 kinds of pipelines are there: outer pipeline and inner pipeline. Right? So crude oil abundant in Earth's crust. This is crude oil. Earth's crust. Just above crude oil, we will get natural gas. This is natural gas. So just like bore wells, we need to make a hole well by drilling. After drilling, we need to insert pipelines. Outer pipeline, if required. If there is no hydrostatic pressure, we need to insert another pipeline, outer pipeline. So when you pass compressed air through outer pipeline, compressed air through outer pipeline. So crude oil. So we need to make holes first down to Earth's crust, then inside the pipeline, pass compressed air through outer pipeline. So crude oil comes out through inner pipeline. Crude oil. Right? This is a simple method that we use in extracting crude oil. So this crude oil composed of 3 kinds of mixtures. 1. Paraffinic base oils. 2. Naphthenic base oils. 3. Mixed base oils. Paraffinic base oils means only long chain hydrocarbons. long chain hydrocarbon. Naphthenic, aromatic. Oils mainly composed of aromatic. Mixed base oils composed of both paraffinic base oils and aromatic related oils. So this crude oil extracted from its scraps contaminated with large amount of water and other impurities. We need to remove impurities. We need to remove water and impurities like sulfur. This process is known as refining. Refining is done in 2 steps. First one, we need to remove water from the water. Just to pass crude oil between the highly charged electrodes. Crude oil between highly charged electrodes. So maximum content of water. So the Earth's crust, obviously in Earth's crust water, abundant water is there. So contaminated with high amount of water, that we need to be remove that water. A large amount of water is there. So we cannot treat. It becomes expensive. So just pass it between highly charged electrodes. H2O breaks into HOH breaks into H plus and OH minus ions. The H plus ions move towards minus pole and OH minus ions move towards plus pole. So dissociates and breaks into ions. For negative ions, OH minus move towards plus pole. Positive ions, H plus ions move towards negative pole, like that. So this you will get pure crude oil. Crude oil free from water. Right. Next, treating it with sulfur. Treating it with cupric chloride. So impurities like sulfur, impurities present in crude oil like sulfur, eliminated by reacting with cupric chloride as cuprous sulfide. So treat this crude oil which is free from water with cupric chloride. If any impurity like sulfur is there in this, they will get precipitated as Ce2S. What impurities like sulfur is there when you treat it with cuprous chloride. So sulfur combined with cupric ions and it will get precipitated as cupric sulfide. So after removing water and impurities, it is called refined crude oil. Refined edible oils. So removal of impurities from crude oil known as refining. Next, third one. So fractional distillation. So of crude oil composed of up to C30 carbons, long chain hydrocarbons. We need to break into smaller. So breaking of crude oil is heavy, composed of up to C30 carbons, chain length. Hydrocarbon, mainly all oil mainly composed of hydrocarbons with the chain length of up to 30 carbons. We need to break into smaller fractions. Breaking of crude oil into smaller fractions, like petrol, kerosene, to get petrol, kerosene, diesel oil, which are very useful for domestic purpose, right? This can be done. For this, we use a fractionating column. This is retard attached with fractionating column. This fractionating long tower consisting of this column, fractionating, also called fractionating column. This column consisting of horizontal stainless steel trays. Horizontal stainless steel trays. Each tray covered with a loose cap, chimney and loose cap, right? Right. Pure refined crude oil or pure crude oil. Pass pure crude oil into retort, where inside this is called retort, right? Where temperature maintained about 420 degrees centigrade. Under 420 degrees centigrade. So these are called trays. Stainless steel trays. Each tray, this is called chimney. Attached with a loose cap. This is called loose cap. Covered with a loose cap, right? In retard, where we temperature maintain about 420 degrees centigrade. Under 420 degrees centigrade, this heavy crude oil composed of up to C30 carbon. So this heavy crude oil easily vaporizes. So vapor form crude oil in vapor form breaks into small fractions. So vaporized smaller fractions. Pass this vaporized broken fractions smaller. C30, C1 to C30, chain length C1 to C30 composed of, break into smaller, C5 to C8, C10 to C16, C10 to C18, C8 into C30, like breaking of heavy fractions into smaller can be done in gaseous form only. So for that we need to temperature to convert thick liquid, crude oil, thick blackish liquid, vaporized under the conditions of high temperature. Inside temperature maintained in retort 420 degrees centigrade. In vapor form only, it breaks into smaller. Long chains break into smaller fractions. So first one, the smaller fractions. When you pop this into fractionating column, it's a reverse to the vaporization. In this vaporization and breaking of heavy fraction into smaller. This is very important. In retort, two steps takes place. One, crude oil, thick blackish crude oil get converted into vapor. Once it is vaporized, in vapor form only, it breaks into smaller fractions, right? So vaporized, broken smaller fractions, pass them into column where condensation takes place, reverse to the vaporization. When you pass these vaporized smaller fractions, as they go up through chimney, they collide with the chimney and they get condensed. When fractions go up, different fractions, C18 to C30, right? C10 to C18, C10 to C16, C9 to C10, next C5 to C8, C6 to C8, C1 to C4. So this the crude oil consisting of chain length up to C30 breaks into smaller fractions. Chain length between C18 to C30. The main chain consisting of number of carbons, minimum 18, maximum 30. C10 to C18. This is broken smaller fractions which are in vapor form, vaporized, broken small into the column. Pass them into the column where they go up. As they go up through this chimney and they collide with the cap. They go up chimney, they collide with the cap and they get condensed. Here first thing is which one condenses first. Naturally, heavy fraction will condense first. So heavy fraction, this first one, heavy fraction. Among them, heavy fraction is this one, having large chain length. C18 to C30, called heavy oil. Next fraction, this one, C10 to C18. This is called diesel oil. diesel oil. Next one, C10 to C16, kerosene oil. Kerosene oil. Next one, naphthenic oil, C9 to C10, naphtha based oil, naphthenic oil, naphthalene. So very important product, gasoline. So chain length of gasoline C6 to C8, up to C8 maximum. Hexene, heptane, octane, heptene, heptine, like that. Saturated, unsaturated carbons. So last one, lighter, composed of C1 to C5, uncondensed gas. Uncondensed gas, it will remain as gas since it is very lighter, having low molecular weight with up to pentane, up to 5 carbons, chain length up to 5 carbons. It may be butane, propane, butane, like this. So very simple process. So after extraction, purification, purified crude oil, pass this into retort where temperature maintained 420 degrees centigrade. Under the conditions of high temperature, crude oil, thick blackish heavy crude oil converts into vapor, and immediately in vapor form easily breaks into smaller fractions, right? So crude oil composed of a long chain length consisting of up to 30 carbons, chain length, main chain, so breaks into smaller fractions, right? This smaller fraction, when you pass this vaporized broken smaller fraction into column where condensation takes place, condensation depends on their molecular weight. The fraction which is having high molecular weight get condensed first. So when you pass this into the column, they pass through this chimney and they collide with the cap, loose cap, and they get condensed based on their molecular weight. So here heavy fraction condensed first, heavy oil, next diesel oil, next lighter one kerosene oil, next lighter one naphthalic, next lighter one gasoline or petrol composed of up to C8 carbons, C6 to C8, maybe hexene, heptane, octane, like that. Saturated, unsaturated. Uncondensed gas. So lighter, since this consisting of lighter chains, lighter up to C5, C1 to C5. So we cannot condense in fractionating column. It is composed of C1 to C5. These hydrocarbons shorter length, with shorter length, pass this into compressor, where it is compressed, and after compressing, lighter molecules come closer, pentane, propane, van der Waals attractions takes place, slowly gas converts into liquid. This type of liquefaction by passing it into compressor, known as liquid petroleum gas, that is LPG. So very important for use for cooking, important domestic fraction, liquid petroleum gas, right? Composed of up to C5 carbons, maximum mainly butane, propane, like that, higher content. Next topic, synthesis of artificial petrol. In liquid fuels, R20 syllabus, R22, Unit 5. This is Unit 5, Fuels and Combustion, Unit 5. Next, synthesis of artificial petrol. Synthesis of artificial petrol, right? So we can synthesize crude oil, artificial crude oil. If you synthesize artificial crude oil, we can get kerosene or petrol, kerosene, diesel oil also, like that. Main important product among this is gasoline or petrol. So we can do this by Fischer-Tropsch process. Name of the process is by Fischer-Tropsch process. Synthesis of artificial petrol by Fischer process. So here we use water gas, raw material that we use, raw chemical. We use water gas. Water gas. Water gas is mainly composed of CO and H2. So combination of both CO and H2. So reaction, n number of CO plus 2 into n number of H2 gives rise to CnH2n alkenes plus n number of H2O. Second, n number of CO plus 2n plus 1 H2 gives rise to CnH2n plus 2 alkenes. We get alkenes. This can be achieved at high temperature. At high temperature, about 250 degrees centigrade, in presence of catalyst, cobalt plus thoria plus magnesium oxide plus Kieselguhr clay, in the ratio of 100 is to 80 is to 5 is to 200. We need to mix in presence of catalyst combination, catalyst of different in the ratio at 250 degrees centigrade. We get saturated and unsaturated hydrocarbons. The crude oil, artificial crude oil, mainly composed of these saturated enes and anes, right? So what is main source of water gas? Very simple. Coal is the main source. First, take coal in a closed container, pass H2O vapor over the surface of coal. So it reacts, this vapor, under conditions of high temperature and pressure, it reacts with coal. This is called coal. Inside taken is coal. Pass H2O vapor over the surface of coal. So it reacts with sulfur. It combines, the vapor combines with coal. Coal mainly composed of carbon, right? Converts into CO and H2. CO plus H2, right? So this combination of both gases is known as water gas. So main component involved H2O vapor. Hence it is called water gas. And this main source of water gas is coal and vapor, right? Pass vapor over the surface of coal, will get CO and H2. The combination of CO H2 gas known as water gas, right? So simple diagram is there. Keeping diagram in mind, you can write steps involved in synthesizing artificial crude oil. From that you will get artificial petrol. These are purifiers. Next, pass it into compressor. Remove impurities. After that, pass into compressor. Then catalytical, pass this gas to catalytical chamber. Catalytic chamber, these are the catalysts that we use in this catalyst. Temperature maintained, same maintenance. Inside temperature 440 degrees centigrade. So after this, pass this into condenser, condenser or cooler. Then you will get crude oil, thick blackish oil which resembles similar to crude oil, known as artificial crude oil. Whether it is artificial crude oil or naturally extracted crude oil, we need to follow same procedure. So we need to break into smaller fraction. That is called fractionation distillation. Same, the previous topic we discussed it. Same, you attach this plant to that. Retard. Next, attach to the plant. A fractionating column. Same. This is a fractionating column. So already we discussed it in the previous diagram, the previous topic about fractional distillation. Same. You need to attach to the condenser. These are the purifiers. First purifier, sodium carbonate, fill it with sodium carbonate. Next Na2CO3 plus Fe2O3 for the removal of impurities. This is called compressor. We need to pass gas at high pressure at 25 atmosphere pressure. 25 atmospheric pressure. This is called catalytical chamber. Catalytical chamber. This is called cooler or condenser. Condenser. Cooler or condenser. Condenser. Let me draw it clearly. Condenser or cooler. Retard fractionating column. C8 into C30, C10 to C18, C10 to C16, naphthalene. Here you will get naphthalene C9 to C10. Here you will get C6 to C8. Here you will get LPG after compression. Right? Same already. Pause this coal gas. Water gas extracted from by this process. Raw material that we use for extracting water gas is coal vapor. Pause this gas, still it contains impurity like sulfur. Pause this water gas. It contains impurities like sulfur. Removal of sulfur takes place. Sulfur. Still it contains, you can remove up to 90%. If any, still up to 10% can be removed in presence of both sodium carbonate and Fe2O3, Na2CO3 and Fe2O3. After removing impurity like sulfur, these two are called purifiers. This is called compressor, where atmosphere pressure maintained 25 atmosphere pressure. Pass purified gas into the compressor. Compress it to 25 atmosphere pressure there. It means you are pumping, you are going to pump into the catalytical chamber. So pump into the catalytical chamber after compressing it to 25 atmospheric pressure, right? So here under 250 degrees centigrade, already I mentioned while writing reactions. This is a main principle and diagram, very important, flow chart. Sufficient. Keeping reaction and diagram in mind, write points in your own words. No need to read line by line, right? So main concept, principle involved in this, right? Next, after purification, pass it into compressor, compress it to 25 atmosphere pressure, then pump it into the catalytical chamber where 250 atmosphere pressure in presence of catalyst. Catalyst composed of cobalt, thorium, magnesia, MgO, magnesium oxide, magnesia, and Kieselguhr clay. So what ratio they mixed? Filled with what ratio? This catalyst filled with catalyst 100:80:5:200, right? So the reaction takes place. This reaction, formation of saturated unsaturated carbons, still they are in gas form, vapor gas form. This formed this gas composed of these saturated unsaturated anes and enes. Pass this into cooler or condenser where crude oil condenses, where this liquefaction takes place. The liquid formed thick black, which resembles crude oil, original crude oil, natural crude oil. So this crude oil is called artificial crude oil. Artificial crude oil. Whether it is artificial crude oil or extracted from its crust. So we need to follow same process, breaking into smaller fractions. For that we need to follow same method. So attach this to the fractionating column, retard, where retard temperature maintained 420 degrees centigrade, and this artificial crude oil in vapor form, it breaks into smaller fractions. Pass these vaporized smaller fractions into fractionating column. As they go up through chimney, they collide with the cap and they get condensed. So based on their molecular weight, heavy fraction condense first. So you will get heavy oil, next lighter fraction, diesel oil, next kerosene oil, next naphthalene, next petrol, next uncondensed gas. Make it LPG. How will you make it LPG? Pour this later gas, uncondensed, composed of C1 to C5 carbons, pentene, pentane, butane, butane, propane, propane. Pass this into compressor, compress it. When they come closer, after compression, van der Waals attractions takes place, slowly liquefaction takes place. Right? This liquefied gas is called liquefied petroleum gas, LPG. Right? Next one, cracking. So in the previous course already you know about cracking, breaking of heavy fractions into smaller heavy fraction into smaller fractions, known as cracking. Cracking two types: catalytical cracking, thermal cracking. So, in presence of heat only, high temperature, breaking of heavy fraction to smaller, known as thermal cracking. Catalytical cracking, in presence of catalyst and at high temperature, breaking of heavy fractions into smaller, in presence of catalyst and at high temperature, known as catalytical cracking. So, I will give one example, simple mark. Decane, C10, H22, break at high temperature, break into C10, pentene and pentane, C5, H10 plus C5, H12, pentane. So at high temperature it can be broken easily into smaller fractions. Breaking of heavy fractions into smaller fractions, right? Chain length consisting of 10 carbons. Here chain length consisting of two smaller fractions. Break into smaller fractions. Broken into smaller fractions at high temperature. Right? So smaller fractions consisting of chains with 5 carbons only. Right? So in the syllabus you have moving bed catalytic cracking, advanced method. Fixed bed catalytic moving. Out of two, moving bed catalytic cracking is more advanced. Moving bed catalytical cracking. So by this method we can obtain gasoline from heavy oil into gasoline or petrol. So this is a principle, only simple principle. You can write even heavy oil composed of C8 into C30, broken into smaller fractions, C6 to C8. Smaller fraction, hydrocarbons with C6 to chain length, hydrocarbons with chain length, all oils composed of hydrocarbons, chain length, smaller fractions, C6 to C8, maybe hexene, heptene, octane, like that, right? So here chain length heavy oil up to C30, this one C30. So your flow chart, you need to practice only flow chart. Keeping flow chart and this reaction in mind, you can write points in your own words. Okay? So heavy oil, raw material that we use, heavy oil for collection, just for collection. This is a catalytical chamber. Zirconia and clay, artificial clay, where temperature maintained 500 degrees centigrade. Then it attached to then pass this into the fractionating column consisting of only one horizontal tray for separation of two fractions only. This fractionating column consisting of fractionated column consisting of only one horizontal. It means it separates only two components. Right. Then pass this into condenser. After this, stabilizer. Right. This is called catalytical chamber. Catalytical chamber. Catalytical chamber. Catalyst is here. Zirconia plus clay 500 degrees centigrade. So you can write here in the reaction also. Zirconia plus artificial clay, temperature maintained 500 degrees centigrade. This is a reaction. Principle is very important and diagram also very important. Flow chart. No need to remember even points also. First one, heavy oil, pass heavy oil into this. Next, catalytical chamber, where reaction presence of this reaction presence of clay, catalyst zirconia and clay at 500 degrees centigrade. This reaction takes place. So formation of this gasoline convert into vapor, and vaporized gasoline breaks into smaller fractions. Right. Further, it is connected to a blower, and then it is connected to separator, regenerator. Where temperature maintained 600. We need to supply oxygen. So this is called condenser. This is called fractionating column. This is called condenser. Here we will get gasoline with impurity like CO2. Here you will get pure gasoline and CO2. Let me explain sequence of steps. First, pour this heavy oil, raw material that we use to obtain gasoline through cracking. So for cracking, pour this heavy oil into this, then pour this into catalytic chamber, where temperature maintained 500 degrees centigrade in presence of catalyst zirconia and clay. So this reaction takes place. This heavy oil converts into vapor. In vapor form, breaks into smaller fractions, gasoline. So breaking of smaller fractions takes place up to 90% only. Still remaining 10% unbroken hydrocarbons, heavy hydrocarbons. So pass this up for the separation of remaining 10% heavy unbroken fractions. We need to send it fractionating column. So you have only this composed of only 90% broken gasoline, 90% every time, 90% remaining unbroken heavy oil. It is vapor form. Both are in vapor form. Vapors. This vapor composed of 90% of gasoline and 10% of this heavy oil. Vapor form. Vapor in vapor state. So pass this fractionating column for separation. As obviously heavy fraction condenses, heavy unbroken fraction 10% which are in vapor form, 90% is gasoline. For separation of we need only gasoline, condensed gas. For separation we need to pass this into fractionating column. Since this vapor composed of only two components, when you pass this into fractionating column, which consists only one tray, horizontal tray. So it goes up, the heavy fractions, obviously heavy fraction condense, unbroken heavy fraction condense. This unbroken heavy fraction again converted to liquefaction, converted into heavy oil. We can reuse, pass it into collector, so that we can reuse for synthesis of heavy oil, can be sent back, reuse. So this broken uncondensed gasoline, pass this into condenser where it condenses. So this condensed gas, gasoline still consisting of impurity like dissolved carbon dioxide. This dissolved carbon dioxide can be removed easily by passing it into stabilizer. This is called stabilizer. These are the steps involved. Maybe I'll use for synthesis 1, point number 2, point number 3, point number 4, point number 5, point number 6, point number 7, point number 8, right? So 7, 8 we'll discuss later. First, let me repeat points that we need to write. After just you need to remember only principle and flow chart. You need to practice for some time. For the raw material that we use for synthesis of gasoline, for this cracking, moving bed catalytic cracking, raw material that we use is heavy oil. Pass this heavy oil into collector and then passed into catalytic chamber in presence of catalyst at a 500 degrees centigrade. This heavy oil converts into vapor and vapor form breaks into smaller fraction. Only 90% breaks into smaller fractions. Still 10% unbroken vapors are there. Vapors composed of both 10% unbroken heavy oil and 90% gasoline vapors. 10% heavy oil vapors. So separate this unbroken. Our purpose is to obtain heavy smaller fraction like gasoline from heavy oil. So we able to, using this method, we able to break 90% only. Separate them by passing it into fractionating column. Obviously in fractionating column, we need to separate only 2. So just it is attached with only one tray, horizontal tray. So when you pass this into fractionating column, heavy fraction condenses. So this heavy oil, liquefied heavy oil, again we can reuse it. We can send it back for reuse, right? After this, pass uncondensed gas, pass this uncondensed 90% broken gasoline, 90% gasoline into condenser, where it condenses. This condensed liquid is called gasoline, composed of only 6 to 8. Still it contains impurities, dissolved impurities like carbon dioxide. This dissolved carbon dioxide can be removed by passing it through the stabilizer. These are the steps involved, 6 steps. 7th, 8th step also very important. So at 500 degrees centigrade, while breaking heavy oil, carbon deposition takes place over the catalyst bed. So once carbon deposition takes place over the catalyst, it becomes inactive. So this catalyst can be reactivated by passing it into the regenerator. This is called regenerator, right? For this, the solidified we attached with carbon particulates. So we need to pass this into this by means of, with the help of blower. This is called blower. So when it pass it by means of blower into this, in presence of oxygen, allow it to burn completely at temperature maintained inside about 600 degrees centigrade. So carbon naturally burns carbon deposited carbon over the surface of this catalyst. So this is a combustible, carbon is a combustible. Carbon converts into CO2, right? This is CO2. So once it is removed, carbon eliminated as CO2, again this can be resent back to this by means of blower only. 7, 8 steps. Let me revise it again. Raw material use converting heavy oil into petrol by this method, moving bed catalytic cracking, is heavy oil, passes into catalytic chamber in presence of zirconium clay at 500 degrees centigrade, breaks into smaller fractions up to 90% only. Remaining 10% unbroken heavy oil can be separated by passing into fractionating column. Again this can be sent back for reuse. Next, pass this into broken vapors, gasoline vapors, 90% into condenser, where it condenses. Still it contains impurities like dissolved carbon dioxide, separated this by passing it through this summer stabilizer. During the process of conversion, this heavy oil into vapor, then breaking, carbon deposition takes place over the surface of catalyst. This can be reactivated by passing it into regenerator with the help of blower, where temperature meter 600, allow it burn completely in excess of oxygen. It converts into CO2. So carbon removal takes place as CO2. Once it is regenerated, reactivated, again this can be sent back to the catalytic chamber by means of blower. Right? These are the 8 steps involved. 1, 2, 3, 4, 5, 6, 7, 8. Last topic in liquid fuels, knocking. So here, for easy understanding, so I am taking a two-stroke engine. So earlier, 10 years ago, we would use two-wheelers, Emma, Suzuki Samurai, so two-stroke engine. All are fixed with two-stroke engines. Two-stroke every cycle, it makes pistons makes 2 strokes every cycle. For generating power. So two-stroke engine, combustion chamber. In combustion chamber, conversion of charge, so combination of vapor of petrol and oxygen, vapor of fuel, maybe petrol or diesel oil or gas plus O2 charge, burns in excess of oxygen, converts into liberate delta H every time. This can be done in combustion chamber by means of piston. Piston makes 2 strokes every cycle, is known as two-stroke engine in combustion chamber. Let me draw a diagram, rough diagram. This is called charge, plug, spark plug, piston, crank, wheel, crank. So 2 strokes. So let me draw one more diagram. So what compression? For easy understanding, I will draw a rough diagram. Same, spark plug, piston, crank wheel, crank. Right. So charge combination of both vapors of petrol and oxygen. Charge means. So when you pass, this can be injected into the combustion chamber. This is called combustion chamber. CC, combustion chamber. In combustion chamber, when you charge enters easily, when piston in the when crank in the crank wheel rotates clockwise. When crank in the crank wheel rotates clockwise, piston move downwards. When piston move downwards, charge will get into the chamber. So its chucks is charged like air pumping of tires, cycle tires like that. So it sucks the charge. When crank in the crank wheel rotates clockwise, piston move downwards, simultaneously charge gets into the chamber. Therefore, work done by the piston is called suction stroke. And the volume of the charge at the end of suction stroke represented by Vs. Volume of the charge at the end of suction stroke represented by Vs. Next, When crank in the crank wheel rotates anti-clockwise, piston move upwards. When it move upwards, inside charge is there. It compresses the charge. Compresses the charge, right? When it in compressed state only, all petrol engines in compressed state only, sparks gets ignited by means of plug. Therefore, it is called spark plug. Spark plug. So, any fuel initial ignition, we need delta H, heat energy. All fuels during combustion produce large amount of it along with carbon dioxide and vapor. So, in compressed state only, this charge gets ignited with the help of spark produced by plug. Therefore, it is called spark plug. Spark plug. So, once spark with the help of spark it gets ignited, starts burning. It will start burning. Start burning. Charge burns. So, when it burns and it exert during the process of burning of charge, it exert pressure on the piston. Piston simultaneously moves downwards. When it moves downwards, simultaneously charge gets inside. This process will continue as long as vehicle in running mode. Once you stop, this stops. So every time it makes two strokes. When crank in the crank wheel rotates anti-clockwise, piston move downwards, it compresses the charge. Therefore, stroke done by the piston is called compression stroke. Compression stroke. And volume of the charge at the end of compression stroke represented by VC. VC. So it makes two strokes. Piston makes two strokes every cycle. So this engine is called two-stroke engine. Two-stroke engine, right? So in compressed charge, in petrol engines, compressed state only charge gets ignited with the help of spark plug. When it ignites, it will start burning. During process of burning, during process of combustion, it exerts pressure on the piston. Automatically, obviously, piston move downwards. Immediately, simultaneously, charge gets inside. This process will continue as long as vehicle is running. So, this process continues. Every cycle, it makes two strokes: suction stroke, compression stroke. Therefore, this stroke is called two-stroke engine. And compression efficiency and amount of heat liberated, that depends on compression ratio. Compression ratio can be defined it's the ratio of volume of charge at the end of suction stroke to the volume of the charge at the end of compression stroke. Compression stroke. It can be represented by formula VC, VS, VC. Compression ratio can be defined as volume of the charge at the end of suction stroke to the volume of the charge at the end of compression stroke. So efficiency of engine and heat liberated depends on this compression ratio. This is called compression ratio. Compression ratio. Right. Okay. Efficiency of two-stroke engine and heat liberated also depend on purity of charge. If the petrol contaminated with kerosene oil, here compressed state only it burns until long branched hydrocarbons are preferable. They occupy the surface area less and the occupied volume occupied will also be less. So preferable hydrocarbons for all petrol engines are branched hydrocarbons, because initial ignition takes place in compressed state only. So convenient hydrocarbons are branched hydrocarbons in petrol. Right? A maximum high content of hydrocarbons in petrol should be branched hydrocarbons, so that they occupy less volume and in this compressed state only they will get ignited easily. Right? If the charge is petrol contaminated with impurities, if the petrol is pure, charge burns easily after initial ignition in compressed state. Charge burns evenly, regularly, properly, like this, completely. It gives large amount of heat. Compression ratio will also be high, and amount of heat liberated during combustion, burning also high, very high. So if petrol is contaminated with long chain hydrocarbons like kerosene oil, diesel oil, what happens? Initial ignition takes place after compression stroke. In compressive state only charges will get ignited. After ignition, if it charge contaminated with impurities like long chain hydrocarbon, petrol contaminated with the long chain hydrocarbon like kerosene oil, diesel oil, so charge burns unevenly. It burns here, unevenly, irregular, randomly. So last portion left here burns suddenly, explosively because of impurities. So it burns suddenly, and the preferable hydrocarbons are branched. Ignition takes place in compressed state. Preferable hydrocarbon volume occupied should be less. If they contaminate with long chain hydrocarbons, after ignition, charge burns unevenly, randomly, irregularly. The last portion left, unburnt portion, burns suddenly, explosively, produce a sound, a noise. That noise is called knocking. Knocking character is a negative word. Knocking character, negative word. Long chain hydrocarbons produce large sound. Long chain hydrocarbons, alkanes, then alkenes, then aromatic compounds, right? So knocking character, decreasing order. So it's a negative order, anti-knocking character. You can it can be expressed anti-knocking character. So long chain hydrocarbons occupy large volume, surface area more, occupy large volume, not preferable in petrol burns in compressed state only. So preferable hydrocarbons or branched hydrocarbons. So if they contaminate with long chain hydrocarbons, produce sound, amount a little bit also less. That explosive sound is called knocking. So long chain hydrocarbons are having high you can give number 3, 4. High knocking character. So anti-knocking character of them. So, positive word. We need to write positive word. So anti-knocking character 4, high anti-knocking character. Next to 3, next to 2, next to 1, like this. So anti-knocking character of petrol can be expressed in terms of its octane number. Octane number of petrol. Octane number for petrol engines. Petrol is a mixture of isooctane. Percentage of octane number can be defined as percentage of isooctane in a mixture of isooctane and naphthalene. Percentage of isooctane in a mixture of isooctane, octane and N-heptane. You can write the formula 2,2,4 trimethyl pentane. Three, 4, 5. 2,2,4 CS3 1, 2, 3, 4, 5. CS3. 2,2,4 trimethyl. Common name of this compound is trimethyl pentane. 2,2,4 trimethyl pentane. Since it is pentane, no unsaturation. CS3 1, 2, 3 H, H2 1, 2, 3 no more H, right? This formula plus combination of N-heptane. 3, 4, 5, 6, 7. CS3, CH2, 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 CS3. So 8 in what ratio they should be mixed? 8:20. 8:20. So long chain hydrocarbon, N-heptane, straight chain. volume occupied surface area is more and volume occupied also more. So content of this in petrol should be mixed with 20% only. Remaining 100% branched hydrocarbons. Branched hydrocarbons are more, having more van der Waals attraction. They're very close is that. So preferable hydrocarbons are only branched. So anti-knocking character expressed in terms of octane of petroleum, then expressed in terms of octane number. Octane number can be defined as is a percentage of isooctane in a mixture of isooctane and N-heptane. So they should be mixed in the ratio of 80:20, right? 20. Right. Next, cetane number. Cetane number or cetane. Cetane number for diesel oils. So preferable hydrocarbons reverse to the petrol engines. Hydrocarbons are long chain hydrocarbons. And so cetane number can be defined as the percentage of N-heptadecane in a mixture of N-heptadecane or octadecane plus naphthalene, right? Octadecane or heptadecane, C17H34 straight chain normal N in a mixture of naphthalene aromatic. So complete reverse to the petrol engine. Diesel engines, preferable hydrocarbons. Initial ignition takes place in diesel engines, combustion chamber of diesel engines, after suction stroke only. After suction stroke, volume occupied by the charge is very large comparatively compression state. If it is petrol engine, petrol charge burns, vapors of petrol plus oxygen, charge burns in compressed state only. After compression stroke only, volume occupied by the charge should be less. Then only charge gets ignited. If it's diesel engine, petrol charge burns after suction stroke. Volume occupied by the charge should be large, more. Therefore, preferable hydrocarbons for diesel or long chain hydrocarbons. So, anti-knocking character of diesel oil can be expressed in terms of its cetane number. It can be defined as percentage of N-heptadecane or octadecane in a mixture of N-heptadecane plus N and naphthalene or anthracene, right? So ratio 80:, they should be mixed in the ratio of 80:20. With this, I conclude my class. We'll meet again in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.